Hey everyone, my name is Brad and I'm a developer advocate for Google Cloud focused on improving the developer experience of using Spark across the platform. Today, I'll be giving you an overview of Dataproc Serverless, also referred to as Spark Serverless, which is a tool to help you spend less time managing Spark infrastructure and more time focusing on your Spark workloads. So in the fall, we made an announcement about Spark on Google Cloud, which is us doubling down and making it a first-class citizen on Google Cloud for all of your ETL, data science, and exploration-based workloads. We're accomplishing this across three key pillars. First, an industry-first auto-scaling serverless Spark offering. This empowers our users to shift from managing clusters to focusing on optimizing their workloads. All of the infrastructure provisioning is taken care of for you. Second is a pervasive Spark experience, where we're integrating Spark with our BigQuery, Vertex AI, Composer, and Dataplex services. You'll be able to access Spark more closely to the interfaces and tools you're already working with, as well as utilize a series of open source Spark connectors to access your data. And last, but certainly not least, we are providing flexibility in how you consume Spark. In addition to serverless and our existing Spark on Compute Engine offerings, we announced Spark on Google Kubernetes Engine, or GKE, giving you the ability to standardize on Kubernetes. In summary, one size certainly does not fit all, so we are ensuring that Spark users can utilize it in many different ways. So, why is serverless important? Well, Spark developers spend approximately 40% of their time writing code, with the remaining 60% going into planning, provisioning, and managing infrastructure. Spark is an extremely powerful data processing tool, and one of the key reasons for this is in the complexity of the number of parameters and knobs that you can tune. So with serverless, the auto-scaling and infrastructure configurations are taken care of for you. You can spend your time focusing on the code while letting us handle the rest. Additionally, you only pay for the job duration with no infrastructure provisioning costs added on top of that. You can submit serverless jobs through the API, but as mentioned, we've also incorporated it into some of our other product offerings. So let's take a look at those. First up, we have Spark on BigQuery. This gives BigQuery users a unified SQL and Spark experience right from the BigQuery console. We have integrated a PySpark editor into the BigQuery console, powered by serverless Spark. Users can write and submit PySpark code against BigQuery data with the same serverless and auto-scaling experience they're used to with SQL. For anyone already familiar with the BigQuery console, you know how convenient this is for SQL, and we want Spark to be equally convenient here. Next up, Dataplex, our unified data fabric. Serverless Spark is integrated with Dataplex, letting you run Spark across all of your data in cloud storage and BigQuery with the unified security and permissions that Dataplex provides from a single interface. Additionally, you'll also have access to a serverless collaborative SQL and notebook environment, and this can be used across all of your data. Lastly, Spark is available through Vertex AI. This is an excellent choice for users looking to utilize Spark for data science and machine learning. You can access your Dataproc clusters through Vertex AI Workbench and then submit serverless jobs via the API. You can use Spark alongside other machine learning frameworks such as TensorFlow, PyTorch, Scikit-learn, and BigQuery ML. The security features provided by Vertex AI are applied to Spark. And lastly, Spark workloads can be integrated with Vertex AI pipelines. Stay tuned for a more detailed look into the Spark and Vertex AI integration as my colleague Nikita walks you through it later today. In addition to all of these Spark experiences, we also have Dataproc, our fully managed data processing service for open source analytics. Dataproc provides greater flexibility in how you can use Spark via three different consumption options. You can go with managed Dataproc clusters on Google Compute Engine for fine-grained cost and performance control. You can take advantage of the ease of use of serverless, and you can also run Dataproc on GKE to standardize on Kubernetes-based infrastructure. My colleague Adam will walk you through a more detailed look into this later today. Okay, so let's take a look at how serverless works. On the left, you can see many of the tools we already discussed. Again, Spark Serverless is built to utilize many of the existing tooling to make running Spark on Google Cloud as convenient and as easy as possible. In the middle here, we see this concept of a Dataproc compute unit. Serverless Spark autoscales via these Dataproc compute units, or DCUs. These provide your jobs with the necessary compute resources to complete your jobs and are also how costs are calculated. With these, the Spark job starts, autoscales, and finishes, and all of the resources are cleaned up automatically. Serverless Spark integrates with storage options on Google Cloud, including Cloud Storage and BigQuery. It also works in your VPC network. In addition to all of this, you can integrate with the Hive Metastore of your choice, such as Dataproc Metastore, as well as with a persistent history server to store Spark logs. Okay, so let's talk a bit more about actually submitting a Spark job. So first and foremost, Serverless Spark uses Spark 3.2, which is something I'm personally really excited about because Spark 3.2 has the Pandas API in it now, which I think is great, and it lets you distribute Pandas jobs very easily and in a serverless environment. In terms of how you can submit your job, you have many different options for interfaces, including the gCloud SDK, the API, the Cloud Console, and Apache Airflow, or Cloud Composer, which is our hosted version of Apache Airflow. GCE resources are provisioned within the customer project itself, including VPC-SC and CMEK, which are both supported. And then GCE resources are hidden from the customer. You can use a service account identity with it. The predefined Dataproc editor role is required, and custom batch roles have been created for this as well. Be careful when specifying the region for the batch, as cross-region egress costs will apply if data is in another region. Just a small caveat there. Now, in terms of execution, serverless jobs have about a 45-second startup time compared to 90 seconds for traditional Dataproc clusters. I will say 90 seconds is already very good, but 45 seconds, of course, is better. This is enabled by packaging Spark and the bare minimum dependencies into the environments that your Spark jobs will run in. Again, Spark 3.2 is supported, and with this, their auto-scaling is actually based on the number of executors that your jobs are requesting. What's important to note here is that Yarn is not used to power Spark Serverless. It's solely based on standalone Spark, and it's built in Scheduler. Serverless Spark also supports custom containers, which lets you provide containers with any of the dependencies or custom configuration that you may want within your environment itself. Your batch jobs will show up in the Cloud Console under the new serverless and batch section, so you can access the status of your job, how long it's been running, or any of the logs or any of the output for it. And again, everything is cleaned up once the batch finishes, with the exception of the logs and the results, which do persist. Now, for debugging, you have a couple options. For each batch, it is accessible from the Dataproc console, as I just mentioned. The Spark history server is also available if it's configured with a persistent history server. And your Stackdriver logs are available as well. What's important to note here is that infrastructure metrics are not included, only Dataproc compute units. Now, this is really helpful in case you wanted to see maybe the job is using a bit more DCUs than you were expecting. Perhaps there's some inefficiencies in the code itself. And this really gives you the option to focus on the Spark jobs themselves instead of needing to resize clusters or the like. So this really just makes this things a lot easier for you. Okay. And then here, just we have a brief example of an end-to-end data science workflow on the platform. So you can start off by using Dataplex, which is our unified data fabric for managing your data and adding security permissions to your different data sources. You can then utilize BigQuery to do some exploratory data analysis. You can also use Spark to maybe do feature engineering or training some of those machine learning models. You can also do some of that machine learning model training with Vertex AI. And then you can rely on Vertex AI Workbench for a one-stop for development and a hosted notebook environment. Okay, so we covered a lot here. We talked primarily about serverless Spark, but we did touch on a few other data science tools within the Google Cloud Platform. work portfolio. So if you want to learn more about these data science tools, I encourage you to go to cloud.google.com/data-science to see our new data science landing page. And then if you want to learn more about Spark on Google Cloud specifically, I encourage you to go to cloud.google.com/solutions/Spark to learn more about that there. Okay, so I wanted to thank you all for watching here, and now we're going to showcase a brief demo of actually using serverless Spark. Okay, so here we are in the Cloud Console, and specifically we are on the Dataproc page. So here we see a couple sections, notably this serverless section with this batches tab. So here is where you would see all of your completed serverless Spark jobs, as well as any that are currently running. So what we'll go ahead and do is press create. And the first thing we'll do is we will provide a batch ID. We will leave this region as US Central 1. And then here you'll see under container, we have a lot of different options available to us, notably this batch type. So if we click on this, we see that we can choose between Spark, Spark R, PySpark, and Spark SQL. We'll go ahead and use PySpark for this one. And for this main Python file, this is going to actually be, well, the Python file that gets run against your serverless Spark runtime. So in this case, I'm just copying this demo file that I have here. Below that, we have some other options. We can add additional Python files. We can choose a custom container image to have this job run on. We can add jar files that we would like the job to have access to. So in this case, I'm actually going to provide the link to the Spark BigQuery connector, which this job relies on. We can add some files. We can add archived files. We can add an arguments. And then here we can also add a service account. Next up, under network configuration, we have some options here. Now, what's important to know about serverless Spark is that you need to configure your network with Google Private Access, which I have done prior to this demo on the default network. So we'll just go with that. Select the subnetwork. We also have the option to add network tags. We can choose a Dataproc Metastore instance that we would like the job to have access to. We can also configure a history server cluster if we have one available. We can add our some Spark properties. We can add labels, and then we can go ahead and press submit. But before we do that, what I want to show you is the equivalent command line. So what we could do is using the gcloud SDK, we can copy this in here, and the job will be the same functionality will be replicated using this command here. So we'll actually just go ahead and close this, and then we'll press submit. So now here is some information about the job that will start populating once the job is provisioned, which again will take around 45 seconds or so. And then here we can see that this job is pending. So what we'll do here is we'll actually just go ahead and skip the video ahead until the job is completed. Okay, so we can see here that the status of the job has changed to succeeded, and there's a total elapsed time of 1 minute and 58 seconds. So now we can click on the job here. And then we have some information here. So here we can see the output of the job. So in this case, I had some print statements that were just configured within the job, and they will show up here. There's also some other logging information in here as well. We can see the number of batch Spark executors that were used. So this can be really helpful for debugging. We can go to the details here and see some of the information of the job. So in this case, just some of the details that I provided previously. And then up here, we can also see the logs in cloud monitoring. And then if we had a Spark history server configured, we would be able to access it here. And that would be using that history server cluster from previously. Awesome. Well, thanks for watching.